Welcome to today's Explainer. We are diving straight into one of the absolute most profound mysteries in all of science. We're going to push way past the boundaries of the familiar night sky and venture into the staggering, almost unbelievable possibility of a multiverse. And we're going to follow the science step by step, starting from what we can clearly, provably observe, right out to the absolute edges of theoretical physics. So I want you to imagine something for a second. What if everything we can see, the stars, galaxies, planets, and even space itself, is only one part of a much larger reality? Now, before we get too carried away, we have to be crystal clear right up front. The multiverse remains a really bold scientific hypothesis, not an established fact. Nobody has actually discovered a parallel universe. But as you'll see, our very best models of the early universe point directly toward this mind-bending possibility. Okay, let's dive into this. Section 1. The universe we can see. When scientists say the universe, they're usually referring very specifically to the observable universe. Because the speed of light is finite, looking out into space is essentially looking back in time. It's kind of like standing on a ship in the middle of the ocean. You are bound by a visual horizon. And because space is constantly expanding, there are regions out there whose light will simply never, ever reach us. So the observable universe is vast, sure, but it is not necessarily the entire universe. So what actually makes up this universe we can see? Well, based on 9 years of data from NASA's WMAP satellite, everything you have ever touched or seen, literally every star, planet, and person, falls into a tiny 5% slice of ordinary atoms. The rest is completely invisible to us. 25% is dark matter, and a staggering 70% is dark energy. We are a tiny, tiny minority in our own cosmos. That brings us to Section 2, Echoes of the Big Bang. Now, we really need to clear up a massive misconception here. The Big Bang wasn't some localized explosion happening inside a pre-existing empty room. That is fundamentally incorrect. The Big Bang was an expansion of space itself. Space began to stretch from an incredibly hot, dense state, eventually cooling down and allowing the basic building blocks of matter to form. If we walk through the timeline, right after that intensely hot, dense start, the cosmos underwent a hypothetical period called cosmic inflation. We're talking fractions of a second here. Fast forward to about 375,000 years, and the universe had cooled just enough for the first atoms to form. This released the oldest light we can possibly see, the cosmic microwave background, or CMB. Eventually, much later, the first stars ignited. But that CMB light, that's our cosmic Rosetta Stone. It carries the physical imprint of those earliest moments. Moving right along to Section 3, the inflationary cosmos. So, the crucial point is that cosmic inflation proposes the early universe went through a wildly dramatic, exponential burst of expansion. It grew by more than a trillionfold in less than a trillionth of a second. Scientists think this was driven by a theoretical inflaton field. Imagine taking a deeply wrinkled balloon and blowing it up instantly to the size of the Earth. To anyone standing on the surface, it would suddenly look incredibly flat and perfectly smooth. You know, scientists didn't just invent this inflation idea for fun. They proposed it to solve some seriously massive problems. When we look at that cosmic microwave background, the temperature is astonishingly uniform in absolutely every direction. How could opposite sides of the universe, which have never even been in contact, have the exact same temperature? Well, inflation answers this perfectly. They were intimately connected before this rapid expansion violently stretched them apart. It explains the flat geometry of our space, and it explains the tiny quantum ripples that eventually grew into all the galaxies we see today. Which leads us to a major shift in our story, Section 4, Theories of the Multiverse. When cosmologists actually sat down and worked out the mathematics of inflation, they realized something kind of alarming. It might be incredibly difficult to make it stop completely. This led to the theory of eternal inflation. Basically, while inflation stopped in our particular patch of space, that rapid expansion might just continue indefinitely elsewhere. This would constantly spawn new, isolated bubble universes, forever separated from us by vastly expanding space. Alan Guth, who is a pioneer of this inflationary theory, noted the completely mind-bending implication of this. He said, anything that can happen will happen. In fact, it will happen an infinite number of times. If space is infinitely expanding and constantly generating bubble universes, an infinite variety of physics could play out. But remember, and this is absolutely crucial, This is a theoretical consequence of a mathematical model. Scientists have not physically discovered these other worlds. Now, before we go any further, we have to address a totally different flavor of the multiverse that you see all the time in pop culture, the many worlds interpretation. This actually originates from quantum mechanics, not cosmology. It proposes that every time a quantum experiment has different possible outcomes, all outcomes actually occur, branching off into newly created parallel worlds. And this brilliantly illustrates why we can't treat these as the same concept. The cosmological multiverse involves distant, physical regions of space-time way beyond our visual horizon. The many worlds interpretation, on the other hand, proposes parallel quantum realities existing right here, in the exact same space and time as us. They have completely different scientific foundations. So for the rest of this journey, we're going to stay focused purely on the cosmological side. All right, Section 5, Searching for Hidden Signatures. So here's the central, ultimate scientific dilemma. How on earth could we know another universe exists if we literally cannot directly observe it? If a bubble universe is separated from us by an expansive space that is expanding faster than the speed of light, no telescope will ever see it. But theoretical physicists don't give up that easily. They ask, could there be indirect evidence? Could we find a fingerprint left behind from a time when things were closer together? Theorists suggest that if these bubble universes formed close to each other in the very early stages of eternal inflation, they might have actually collided, and that collision could have left a scar or a distinct bruise on our cosmic microwave background. Scientists have scoured the CMB data for anomalies, like the famous cold spot. But to be scientifically rigorous here, while these anomalies are fascinating, they are just hypothetical tests. There is absolutely no consensus that they are definitive proof of anything. Let's step back and see how this all builds together in Section 6. What does the evidence say? Okay, so this is how we map out reality today. Look at the established column. Here we have rock-solid observations, cosmic expansion, the cosmic microwave background, and galaxy formation. Then, in the theoretical column, we have cosmic inflation, eternal inflation, and bubble universes. They beautifully explain our observations, but they remain unconfirmed. And finally, the unknown. Do these other universes actually exist? We simply do not know. And that brings us to our final stop, Section 7, the ultimate mystery. The renowned cosmologist George Ellis describes something called a physics horizon. Because we are strictly bounded by the speed of light and the energy limits of our colliders, there is an absolute limit to what we can scientifically test. Our observable universe might truly just be one microscopic patch on the grand tapestry of a multiverse. But if that larger reality sits permanently beyond our horizon, well, it tests the very definition of science itself. We have peered back to the first fractions of a second of creation. We can see billions of galaxies, but perhaps everything we can observe is only one small piece of reality. If another universe exists beyond ours, will humanity ever know?